Hello and welcome to the new episode of the 2 Vlog. Today we're going to dive a little bit deeper into the technology with regards to emission requirements, available products, how to meet those emission requirements. And today this episode is quite special, or in a special format. So we will be having a video call together with Lisa Barber of CEM Engineering based in Canada. Lisa, first of all, thanks a lot for your contribution. Thanks for being part of our little vlog of the 2 Vlog. And good morning to Canada. Hope you feel comfortable.
Yes, good morning, Stefan. Thank you very much. It's certainly a pleasure to be on the 2G vlog, and it's exciting. Looking forward to it today.
Okay, great. Well, as I said, we're going to speak about the technical requirements today in certain markets, available products with regards to emissions, and also with regards to the future. So how will the energy market look like, and what is the path to carbon neutrality in the future? But first of all, Lisa, maybe you can introduce yourself and also CEM to everybody a little bit.
Yeah, sure. No problem, Stefan. Thank you. So I started off actually in the emissions control industry, so somewhat relevant to today's discussion. It was with a company by the name of DCL International. They had offices in Europe as well as in the US. And there I handled actually multiple markets. So I started off in the construction and mining, we'll call it markets or territories. And then I moved on to handle material handling, natural gas compression, and basically the yachting sector. So I'd been around emissions for quite some time. When I left DCL, I focused on a company by the name of Express Integrated Technologies. And again, it was emissions related in the sense that I was in charge of SCR business development. And that was actually for very large simple cycle catalyst systems and heat recovery steam generators in the 60 to 100 megawatt range, and for turbines specifically. I've been in emissions for quite some time, and then about 4 years ago, I was fortunate to land my current role at CEM. So I'm the director of business development here. As far as CEM goes, we were founded in 2001 by our he was, I guess, our principal in charge, Martin Lensink. The company has since changed ownership. Matt Lensink is now our CEO, and that's Martin's nephew. And so the company really was predicated on trying to serve Ontario, the Ontario client base, by reducing clients' energy costs and striving to meet the client's environmental goals. We've really expanded kind of the markets that we focused on over the years. So CEM stands for cogeneration and energy management, which happen to be 2 of our core competencies. But in addition to those core competencies, we also focus on cogeneration, power generation, boilers, district energy, energy management, biomass, biogas, RNG, and hydrogen. Ultimately our goal as an engineering firm is to help simplify, the complexity of these projects, because as you can imagine, some of the topics and discussions we can get into are quite complex.
Yeah, that's really big portfolio. And then what you were saying, we're a manufacturer of CHP plants. Of course, our portfolio is to a certain extent similar. But what you were saying, the simplicity, this is what customers really appreciate. So making complex things similar and easy to understand. And as I said, this is also what our customers really appreciate a lot. You were mentioning so many different things you're doing. So what is your, let's say, SCM, your strength, or what is your USP towards the customer?
Yeah, so ultimately, Stefan, what we like to do is try to make things, we want to make things easy for our customers. We've developed a kind of a gate process, I like to call it, over the last couple of years that we refer to internally as the stairway to heaven, because of course a project is heaven. But ultimately, what we're doing there is we're taking a very distinct and specific gate process to identify specific steps on how to get from point A of a project, so from the initial business case, for example, to maybe more of a detailed study so that someone can understand, where the capital costs and the savings might look like on a project. And then we try to bring them before a project is actually approved, internally by a company. We bring them through what's called front-end engineering design. And so that basically consists of highlighting any of the red flags that might exist. That could be from an air and noise perspective. It could be from a municipal perspective. There's a variety of things, of course, and complexities that come around, a CHP facility. So we try to simplify that as much as we can. And we understand that we have to simplify our language in such a way that we're speaking to multiple stakeholders, because somebody who's in engineering obviously understands what we're talking about, and we don't lose them in the conversation. But if we're speaking to somebody who's in finance about the complexities of the project, and we start to get into too much of a technical language, we lose them, right? So we want to make sure we're speaking to everybody. And ultimately, what we're really trying to do is get the client to understand that a project can be technically feasible, it can be financially feasible, but is it constructible? And so we want to make sure that we have all three elements, and that's part of that gate process, so that we can make the client feel comfortable, but that they have all three aspects of the project included.
Yeah. Okay.
And then in addition to that, I think obviously, 2G has a similar approach, which is why we love working with you guys. Because I think you guys, try to do something quite similar in a sense as well.
Yeah, definitely. I mean, at the end, it's about understanding the customer, so having the right products for the right customers in the right markets. I mean, we grew up out of the German biogas market, which is, of course, entirely different compared to the projects, for example, we're doing with you currently in the US or in Canada. So, and then you have to treat each customer in a different way. Entirely. And then additionally, for example, 2G, we are a stock listed company, and also the communication towards the stock market is entirely different. So it's really, it's important to address all the different shareholders or stakeholders in their specific manner. What goes into the same direction, is the emission side. So when we're talking about the different requirements of different markets, and you were saying already you are in different markets, and we are as well globally. So in terms of emissions, can you give us some examples about the differences in requirements with regards to emissions?
Yeah, no, sure, for sure. It's so I'll use the Ontario context actually to start off with, because it's quite interesting and can be quite unique in how the Ontario market approaches emissions. So essentially, if you think of like a backup generator, for example, that can run up to 50 hours per year, which by our Ministry of Energy guidelines, that's kind of the cutoff point before you have to integrate emission controls. So up to 50 hours, you don't need emission controls on anything that's standby or emergency related. But anything over 50 hours, so let's say, a client wants to use a diesel or a natural gas-fired backup standby generator for perhaps GA mitigation or Global Adjustment Mitigation Ontario, they would be required to put on emission controls. So whether that's a DPF, a diesel particulate filter, SCR, selective catalytic reduction, or a three-way catalyst, depending on the type of engine, they would be required to do that, certainly for any applications that have to run over 50 hours per year. And then in addition to that, there's not necessarily different requirements in terms of the overall emission requirements still need to be met, but naturally the differences between rich burn and lean burn technologies, engine technologies, will require different types of emission controls, right? You have SCR on a lean burn engine and three-way catalysts on a rich burn engine. So that's, there's some differences within just the Ontario context. And then as you start to go, south of us into the US, that's where things can get quite interesting. I guess in some ways similar to Canada, where it's on a provincial basis that emission regulations change. The same it's the same basically in the US, where things will change on a per state basis. And interestingly enough, we understand that 2G has their own SCR system now. So we were really excited to hear that, because especially from my vantage point, where I was in emission controls for a very long time, it can be a risk on a project. So to have someone like yourselves integrating that yourselves is quite fascinating and quite interesting.
Yeah. Yeah, I mean, as you said, the own SCR system, yes, we have it. I mean, 2G, we are focusing on engine development, or also on the development of engine parts also for many, many years now. So we started with our own R&D company at that time called 2G Drives already back in 2010. And then, of course, our experience is increasing. And as I said before, we're active in so many different markets. And like you said, I mean, there's even within one country, there are so many different regulations and requirements. And again, it's very important to have this broad network. I mean, it's not only the SCR catalyst system when it comes to emissions. We have even our Aura series, yeah, which is an entire CHP series only dedicated to those kind of emission topics. And the trigger, for example, came out of the UK at that time, so from our UK subsidiary. So this to have the network over the world in order to be able to develop the tailored solutions, this is very, very important. But coming back to the SCR system, I'm pretty sure that maybe not everybody knows about the details of what an SCR is. So, I mean, we are now talking about all the details. But maybe it's good to have a short overview, and we have prepared a little video with one of our experts, Christian Langermann, and let's have a quick look at this little video.
I'm standing in front of a lean combustion gas engine, which is a very clean engine already. However, the requirements on health and environmental protection become higher and higher, and therefore we need to meet stricter emission requirements. For this purpose, we developed SCR systems, which are intended to reduce nitrogen oxide emissions, carbon monoxide, and different types of hydrocarbons. One of the main design criteria was that we have spare layers in our SCR housing. This means that you can support your worn-out catalyst by a new one instead of just wasting it when it's not completely used. This reduces your overall lifetime cost significantly and allows you to maintain low emissions for a long period of time. For the SCR reaction, we need a perfect mixture of urea and exhaust gas. This happens in the mixing duct. It is mainly designed to allow the injected urea to evaporize and mix with the exhaust gas. And as a reaction agent, we use AdBlue, diesel exhaust fluid, or AUS23, which is actually all the same. The urea injection is managed by the dosing system, which is basically the whole train from the injector to the urea storage tank. In this train, high quality components are used, and it is fully integrated in our plant control. This allows very high service and user friendliness.
Thanks to Christian.
Wow, that was something, quite something.
Yeah, it's always also for me really impressive to listening to his content. I mean, internally, quite funny, we call him the godfather of emissions here. So he has really a lot of knowledge on this specific field. Maybe we can have a look at the broader scope now. I mean, of course, emissions are important, but only one little piece. And I mean, many regions in the world have identified to be carbon neutral as one of their core goals. In their societies, and even in Europe, Europe has decided to become carbon neutral until 2050. Yeah, so and there are currently lots of discussions taking place in all of the European countries, and how can we reach those goals? Because of course each of the countries has different, has a different situation. So some still rely on atomic power, on coal power, on gas power. Some have even increased their amount of renewable energies quite a lot. So what is the situation in Canada or in the US? How do you see that? And what is CEM doing or developing in order to meet those, let's say, global discussions or goals?
Yeah, great question, Stefan. So here, at least in North America, there's certainly a significant debate between electrification and the use of our natural gas distribution system. And there are some people that are more, one-sided than the other. I personally believe that it's going to require a bit of a blend of the two technologies. In our case, at least, where if we expand electrification rapidly, there's certainly going to be significant costs associated with that. And that's mainly just because there's more infrastructure that needs to be built. So when we think of things like electric vehicles, for example, and how that will be connected to the distribution system, there's maybe some challenges there. And then we think about our natural gas distribution and what that currently can provide to clients. And one can't help but think what that would look like if we start to inject renewable content, whether that be in the form of renewable natural gas or hydrogen. We have lots of organics and lots of waste, lots of dairy farms and manure available to create that renewable content. So when we think about transporting that through the natural gas distribution system, decreasing fossil fuels in existing boilers or other pieces of equipment, industrial use equipment that's run on fossil fueled natural gas, I think there's a significant advantage there. Obviously, using either of those fuel streams through on-site combined heat and power, or CHP, another great option. And so the debate exists again between those, between electrification and natural gas. And I don't know if anyone has heard, over in Germany, but Trudeau has just recently announced here in Canada, through his climate strategy, basically a plan to increase carbon tax up to $170 per ton by 2030. And that's quite significant, considering that we're at $30 a ton currently, with $40 a ton coming next year and $50 the following year. So that's going to impact the business case quite significantly. And so we're already starting to have lots of discussion with clients on the use of renewable natural gas, and in some cases that's anaerobic digestion on site that is then powering a CHP, and that is injecting whatever might remain of that biogas, cleaning that up through a membrane system and injecting that into the distribution system. In other cases, it's hydrogen creation on a site using electrolysis, putting that through engines. We're having so many of these different discussions, and I think that while some of the discussions might be in its infancy, we really need to get to a point where the business case makes sense, right? So that perhaps is a bit of the struggle, but it's really stepping stones to get us to that. And obviously I think we can get there. It's just a matter of time, and how do we get there exactly?
Yeah. It's really, really interesting what you're saying, because we're having almost the same discussion, and then the central thing you said, this discussion between electrification and natural gas use, or use of the existing grid, and this is exactly what happens here in Germany or in Europe. And of course, we all know, or we all have this big goal, 2050 being climate neutral, of course. Mm-hmm. But with pure electrification, it's hardly possible, or it's not possible. I mean, you were mentioning the electric vehicles. Of course, that's a perfect possibility to store energy, but in the short term. So you do not have the seasonal storage, and it's just not possible. You cannot build up any battery cities or whatever. So exactly the same situation. Of course, in an electric vehicle, for example, absolutely useful. But I mean, you can even increase, there are several studies and numbers, you can even double or have 3 times the amount of renewable energies in terms of wind energy and solar energy, but nevertheless, you cannot store it. When the wind is not blowing or the sun is not shining, you cannot just store it. So you need to have a kind of backup system. And this is where the natural gas infrastructure comes. And of course, we should not stick to natural gas, or the discussion should not be, okay, we should stick to natural gas over years, of course not. But especially CHP can be the backbone technology, and any installation of a CHP today can be used with hydrogen tomorrow. I mean, you were mentioning that already in your answer. Thanks for that. And this would also lead me to the end of the discussion. So as I said, hydrogen, it's really or it's becoming a bigger topic, or it's one of the it's perceived as one of the potential keys or the potential solutions for exactly that backbone technology. And as I said already, in use of the CHP plant. How is the situation of hydrogen in general in Canada, and how do you see the potential use in CHP plants?
Yeah, that's a good question. I think a lot of that has to deal with where the hydrogen is coming from a geographical sense. So if we're talking about the Ontario market, we're likely talking about more electrolysis on a site, or maybe it's hydrogen that's delivered through the natural gas distribution system and it's blended in with the RNG, or it could be hydrogen tanks that are brought on site. And again, depending on the run hours of the engine or the CHP system, a blend of that hydrogen to RNG. I think that's what a lot of customers are starting to look at, where it's not necessarily running an engine at this point on 100% hydrogen, but to have the ability to do that is certainly a big bonus. But if they can inject 5% hydrogen or 10% hydrogen, just to start to get them to that sustainability goal that they might have set for 2030, or just based on more aggressive targets, to step that up every year or every 3 or 5 years, that's what a lot of customers are certainly looking at. But then if we look at Alberta, for example, and getting hydrogen based on old natural gas or oil wells and extracting it from those sources, it's a different type of hydrogen. It's not known as green hydrogen, but that's certainly a huge possibility for the province of Alberta, and I think they will probably play a major role in hydrogen use and creation in Canada.
Yeah, that's again nice to hear. I mean, as you may know, we have already, for us, it's not only R&D work anymore. So we have CHP plants that run on 100% hydrogen already. So not only in Germany, also in other parts of the world. So it's not only a study anymore. It's real life, and it's a real business case. So we can see there is a market and there is a potential in the future. And when you tell those kind of things about Alberta, that's really nice to hear. But maybe to sum it up or to come to the end, I mean, at the end, it's not only about one source or the other source. I think at the end, and we all agree on that, it's a combination. So it will be a mixture of different sources, of different storages, and of course, with the digitalization, the efficient combination of everything. And I think this is the key, and this is also the path we should follow in the future from my point of view, or from our point of view. Do you have anything to add right now?
Yeah, no, absolutely, Stefan. Everything you said there was great, and CM feels the same way. It's for that reason that we've really invested ourselves in a number of other core competencies, as I mentioned earlier. So again, while we were mainly known for cogeneration for many years, just because there was a big enough spark spread in Ontario, and that's kind of where we built our name. Now we're just there's more conversations happening on the hydrogen and RNG front. And maybe the only other thing that I would add is, I think the business case is close. I think we're getting closer every day, which is quite encouraging. Yeah. And the only other thing, I think that we could probably have just to kind of advance that business case or just the development of projects would probably be incentives that would come from, the federal government or provincial governments. And I think if we had those, that would fast track. And I know the government is thinking of putting something out. So we're certainly looking forward to seeing how that will impact our business and help our clients out.
All right. So thanks a lot, Lisa. It was really a pleasure. Was great. Thanks a lot.
Yeah. No problem, Stefan. Thank you very much. It was a pleasure to be, on the vlog here today. I appreciate your time, and yeah, it was a fun opportunity. Thank you.
All right. Stay in contact, and yeah, thanks also for you. Thanks also to you for listening, and yeah, please like us on Facebook. Send any kind of comments, and yeah, if you want to get more information about our products or the products of CM, yeah, just get in contact with us. Bye bye.
Goodbye from Canada.